The IEC, EU, and UK wiring color code for a 400V/230Y system utilizes specific colors to identify phase conductors, neutral conductors, and protective earth conductors, which is ground. For phase conductors, brown designates low, which is phase A, black designates L2, which is phase B, and grey designates L3, which is phase C. The neutral conductor is blue, designated as N. The protective earth conductor, or ground, is green-yellow, designated as P. It is essential to understand that the 400V/230Y system represents a three-phase system where the line voltage, measured between any two phases, is 400V, and the phase-to-neutral voltage, measured between any phase and the neutral conductor, is 230V. This configuration is common in many industrial and commercial settings throughout Europe and the United Kingdom. Before connecting any equipment, especially imported machinery, it's absolutely critical to ensure the transformer being used is adequately sized to handle the load and voltage requirements of the machine. An undersized transformer could lead to overheating, voltage drops, and potentially damage to the equipment or the transformer itself. Conversely, an oversized transformer, while not immediately harmful, can be less efficient and more costly than necessary. The proper sizing of the transformer involves calculating the total volt-amps or kilovolt-amps required by the machine. This calculation should take into account the machine's rated power, power factor, and any potential surge currents during startup. Once the volt-amp requirement is known, select a transformer with a volt-amp rating equal to or slightly greater than the calculated value. Wiring the transformer correctly is just as crucial as sizing it properly. The primary side of the transformer, which is connected to the supply voltage, must be wired to match the available voltage. In this case, the transformer is designed to convert 240V delta to 400Y/230V. The secondary side, which supplies power to the machine, must be connected in a Y configuration to provide the required 400V line-to-line and 230V line-to-neutral voltages. Ensure that the phase sequence on the secondary side matches the machine's requirements. Incorrect phase sequence can cause motors to run in reverse or other equipment malfunctions. Grounding is another essential aspect of the wiring process. The protective earth conductor, or ground, must be properly connected to the machine's chassis and to the grounding system of the building. This provides a low impedance path for fault currents, which helps to protect personnel from electric shock and minimize damage to equipment in the event of a fault. The green-yellow wire should be connected to a designated grounding point on the machine and to the main grounding busbar in the electrical panel. When working with electrical systems, especially those involving high voltages like 400V, safety should be the top priority. Always to energize the circuit before starting any wiring work. Use appropriate personal protective equipment, including insulated gloves, safety glasses, and insulated tools. Double-check all connections to ensure they are tight and secure. Loose connections can cause overheating, arcing, and potentially lead to fires. Furthermore, it is highly recommended to consult the local electrical codes and the manufacturer's instructions for any specific requirements or recommendations related to the wiring of the imported machinery. These resources may provide valuable information about the machine's specific wiring needs, grounding requirements, and safety precautions. It is also crucial to understand the relevant regulations and standards governing electrical installations in a specific country or region where the machine is being installed. These regulations may specify requirements for wire sizes, conduit types, overcurrent protection, and other aspects of the electrical system. It is always best to hire a qualified electrician to perform the wiring and ensure the safety and proper operation of the equipment. Qualified electricians have the knowledge, skills, and experience to perform the wiring work safely and in accordance with all applicable codes and regulations. They can also identify potential hazards and address any issues that may arise during the installation process. Attempting to perform electrical work without the proper training and experience can be dangerous and may result in serious injury or property damage. Therefore, it's essential to leave the wiring work to the professionals. In summary, when wiring a 400 volt/230Y system according to IEC, EU, and UK standards, remember that brown is phase A, black is phase B, grey is phase C, blue is neutral, and green-yellow is ground. Always ensure proper transformer sizing and wiring, grounding, and adherence to local electrical codes and manufacturer's instructions. And most importantly, prioritize safety and hire a qualified electrician to perform the work. This ensures a safe and reliable electrical system for the imported machinery. The importance of consulting the local electrical code cannot be overstated. Electrical codes vary from country to country, and even within countries there may be regional or local variations. These codes specify the requirements for electrical installations, including wiring methods, materials, and safety devices. Failure to comply with the local electrical code can result in fines, delays, and potentially unsafe conditions. Therefore, it's essential to familiarize yourself with the applicable electrical code before starting any wiring work. This can be done by contacting the local electrical inspector, consulting with a qualified electrician, or researching the code online. The manufacturer's instructions are another valuable resource that should not be overlooked. The manufacturer of the imported machinery will typically provide detailed instructions on how to properly wire and connect the equipment. These instructions may include information about the machine-specific wiring requirements, grounding recommendations, and safety precautions. Following the manufacturer's instructions carefully can help to ensure the proper operation of the machine and prevent damage or injury. If the manufacturer's instructions are unclear or incomplete, don't hesitate to contact the manufacturer directly for clarification. They should be able to provide additional information or guidance on the wiring process. In addition to the color codes and wiring procedures, it's also important to understand the function of each conductor in the system. The phase conductors, brown, black, and grey, carry the electrical current from the source to the load. They are typically connected to the terminals of the machine that are designated for the phase inputs. The neutral conductor, blue, provides a return path for the current. It is typically connected to the neutral terminal of the machine. The protective earth conductor, green-yellow, provides a safety ground. It is connected to the machine's chassis and to the grounding system of the building. In the event of a fault, the protective earth conductor provides a low impedance path for the fault current to flow back to the source, which helps to trip the circuit breaker and protect personnel from electric shock. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from damage caused by excessive current flow. These devices are installed in the electrical panel and are sized to protect the wiring and equipment from overload and short-circuit conditions. The size of the overcurrent protection device should be based on the ampacity of the wiring and the rating of the equipment being protected. It's important to select the correct size overcurrent protection device to ensure that it will trip in the event of an overcurrent condition but not trip unnecessarily during normal operation. Regular inspection and maintenance of the electrical system are also essential for ensuring its continued safety and reliability. Electrical systems should be inspected periodically by a qualified electrician to identify any potential hazards or problems. This inspection should include checking for loose connections, damaged wiring, and malfunctioning equipment. Any problems that are identified should be repaired promptly to prevent them from escalating into more serious issues. Maintenance tasks such as tightening connections and cleaning equipment should also be performed on a regular basis to keep the electrical system in good working order. Finally, remember that working with electricity can be dangerous. Always take the necessary precautions to protect yourself from electric shock and other hazards. Wear appropriate personal protective equipment to energize the circuit before starting any work, and double-check all connections to ensure they are tight and secure. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. By following these guidelines, you can help to ensure the safe and proper operation of the electrical system for the imported machinery. Firstly, correctly identify and label all conductors using appropriate color-coded markers. Secondly, use appropriately sized conductors according to the NEC Table 310.15 to handle the anticipated current load, remembering to account for ambient temperature and conductor bundling when determining ampacity. Thirdly, install overcurrent protection devices, like circuit breakers or fuses, with appropriate interrupting ratings to protect circuits from overloads and short circuits, typically adhering to NEC Section 240. Fourthly, ensure proper grounding and bonding of all metallic equipment and enclosures to provide a low impedance path for fault currents back to the source, following NEC Article 250. Fifthly, use approved wiring methods suitable for the environment, such as rigid metal conduit, electrical metallic tubing, or cable trays, complying with NEC Chapter 3. Sixthly, maintain proper clearances and working spaces around electrical equipment for safe operation and maintenance, following NEC Section 110.26. Seventhly, install appropriate warning labels and signage to clearly identify voltage levels, hazards, and emergency procedures. Eighthly, use properly rated and listed electrical components and equipment that meet recognized standards such as UL or ETL. Ninthly, document all electrical work with accurate and up-to-date drawings, specifications, and records for future reference and maintenance. And tenthly, perform thorough testing and commissioning of the electrical system to verify its proper operation, safety, and compliance with applicable codes and standards, conducting tests like insulation resistance, continuity, and ground impedance checks. Remember that electrical codes and standards are constantly evolving, so it is essential to stay informed about the latest requirements and best practices. Regular training and continuing education can help electricians and other electrical professionals stay up to date on the latest changes and advancements in the field. Furthermore, it's important to recognize that electrical safety is not just a matter of compliance with codes and standards. It's also a matter of attitude and personal responsibility. Electrical workers must be committed to working safely and taking the necessary precautions to protect themselves and others from electrical hazards. This includes following safe work practices, using appropriate personal protective equipment, and being aware of the potential hazards associated with electrical work. In addition to the technical aspects of electrical wiring, there are also a number of soft skills that are essential for success in the electrical field. These skills include communication, problem-solving, teamwork, and customer service. Electrical workers must be able to communicate effectively with clients, colleagues, and other stakeholders. They must be able to explain technical concepts in a clear and concise manner, and they must be able to listen to and understand the needs of others. Problem-solving skills are also essential for electrical workers. They must be able to diagnose and troubleshoot electrical problems, and they must be able to develop creative solutions to complex challenges. Teamwork is another important skill for electrical workers. They must be able to work effectively with others to complete projects on time and within budget. Customer service skills are also important, especially for electrical workers who work directly with clients. They must be able to provide excellent customer service and build strong relationships with their clients. In conclusion, electrical wiring is a complex and challenging field that requires a combination of technical knowledge, practical skills, and soft skills. By mastering these skills and following safe work practices, electrical workers can help to ensure the safety and reliability of electrical systems for homes, businesses, and industries around the world. For example, NEC 310.16 provides ampacity tables for conductors. NEC 250 covers grounding and bonding requirements. NEC 240 addresses overcurrent protection, and NEC Chapter 3 details wiring methods and materials. Remember to consult the specific edition of the NEC that is adopted in the jurisdiction where the work is being performed, as requirements may vary. A 480-volt system, for example, might require different wiring methods and protection strategies than a 120-volt system. Similarly, the requirements for grounding and bonding can vary depending on the type of system and the location of the equipment. To ensure the safety and reliability of an electrical installation, it is essential to carefully consider all of these factors and to follow the applicable codes and standards. And when in doubt, it is always best to consult with a qualified electrical engineer or inspector. The principles of electrical safety extend beyond just compliance with codes and standards. They also encompass a culture of safety that permeates all aspects of electrical work. This culture of safety starts with training and education, ensuring that all electrical workers have the knowledge and skills they need to perform their jobs safely. It also includes providing workers with the proper tools and equipment, as well as ongoing support and supervision. Perhaps most importantly, a culture of safety requires a commitment from all levels of the organization, from management to frontline workers, to prioritize safety above all else. This means encouraging workers to speak up if they see something unsafe, and it means taking swift action to correct any hazards that are identified. By creating a culture of safety, organizations can significantly reduce the risk of electrical accidents and injuries. And by continuously improving their safety practices, they can create a safer and more productive work environment for everyone.